Hi there, welcome to Mini Math Lessons with Karen, and today we're looking at two activities, middle school, probably algebra level, that are dealing with proportional reasoning. And so they're both kind of real world applications of when you might be using proportional reasoning and thinking and ratios and scale, those types of things. So I'm using Classpad.net. That's this free math all-in-one software. You notice you can do anything with it. This is the landing page, and you don't need to have an account. You can just start exploring and playing, and you can use the two activities that are shared in the link below. You can use them without having an account, but I highly recommend having an account because if you like what you're doing and you want to save it, you need to be able to save it to an account. And if you want to make modifications or you just want to start creating activities on your own, an account is helpful. So here's how you create a free account. All the accounts are free. So have fun playing with that. Let's get into the activities. So the first activity is basically comparing the height of objects. And these are two candles. They start at the same height and they burn at a different rate because they're made of different wax. And so you'll see one candle takes 12 hours, the other one takes 8 hours to burn completely out. So the first thing students are asked to do is to basically write a ratio fraction that represents how much of a candle is burning each hour. So if it takes 12 hours, then every hour they are burning 1/12 for the first candle, and every hour they are burning 1/8 for the second candle. So if they had to compare right now which candle is burning faster, they could look at the fractions and compare them, or they could just kind of understand if this one takes 12 hours, it's obviously burning at a slower rate than this one. So then once they talk about the candles and comparing them, how do you know which one's going to be taller after just a little bit of while? How do you know that? And then they're going to actually collect some data. So one thing to point out if you're going to do this with your students is to notice that they're in the table, they want to know what's remaining of the candle, not how much has burned. So that's a different, context, so make sure that they're paying attention to that. So you'll notice that both candles start at 1, and 1 could represent the height, or it could just mean the whole candle. Right? So if we're thinking about fractions, the 1 is the whole. So now how much is left after an hour in each candle? Well, if candle 1 is burning 1/12 every hour, then after the first hour, there are 11/12 left. So we could calculate out what that means. And so in here, we would record 0.92. And for the candle 2, if it's burning 1/8 every hour, then at the first hour, it has 7/8 left. It's not whole anymore, and so it's at 0.88. So you can automatically, as we would expect, the one burning faster is going to be shorter, right, after each hour. And so we're going to continue to collect the data that way. So at hour 2, if we had 12/12, now we have 10/12, right? So they're going to calculate all of that out. So they're going to fill out the table, use the calculator, however that works for them, and record everything. So I'm going to pause for a moment to finish filling out the table, and then I'll come back. All right, so we're back. There's the table is now filled out, calculating. And so you could have them do some comparisons right now. When is candle 2 half the height of candle 1? Remember, they start at the same height, and that's something kids need to remember of this situation. They both had the same height. So when candle 2 is halfway done, it's half the height of the original. But then when is it half the height of at the same time? Is it ever half the height of the candle 1 at the same time? So these are kinds of interesting questions you could ask. So what we're going to do now, I just want to show you what it looks like as a graph. I'm going to plot a scatter plot of each of them and bring that up. Oh, yellow's a terrible color. Let's change yellow. There we go. And here's my scatter plot. So if you see, it's a constant rate, right? Because it's burning 1/12 per hour. So this is what the first candle looks like, constant rate. And what do we already know about candle 2? It's burning faster, so it should have a different slope, right? It should be burning faster. So let's compare that, and hopefully that's going to give us a nicer color here, blue. So you can see it's going much faster. And so you could also talk about when are they, you could use the graph to help you visually see when is candle to half at the same time, half of candle 1. Is there a place? Is there a position? So they can look at the graphs, they can look at the table, they can look at the ratios, the proportions, and calculate, whether it's half, those types of things. So I'm just right here, I'm kind of looking, right? That's one place. So they're going to explore all of that, and they're going to then create some equations that model this. So that's where this activity is going. It's really thinking about the rate, constant rate, unit rates, those types of things. Let's go into the second activity. This is one that I really like because it really is a topic that students seem to struggle with, this understanding of the ratios. If you are increasing the dimensions of a geometric object, in this case a rectangle, if you double the sides, how does that impact the perimeter and the area? And this is an application problem because we tend to have to do this when we're thinking about framing something, right? So it's a really nice problem. So this is about a rectangular picture, and this person has lots of rooms they could put it in, so they may reduce it or they may enlarge it. And they know that right now it's originally going to fit in a frame that's 8 by 12, right? So those are my dimensions, my length, my width. And then I also want to cover the picture with a protective sheet of glass. Now, kids might have a hard time understanding why is that information in there, but if I'm going to put glass over that image that's in this frame, same dimensions, but I need a whole glass in the inside, that means I'm thinking about area. So this is really comparing perimeter and area. So this activity has a nice couple simulations in it. And first one is, let's just collect some data and try to get a sense of what's happening to perimeter and area. So we're starting with a square, not the dimensions of our picture at this first thing. We're just starting with a square, because a square, if you change one side, you've changed length and width at the same time. So it's sort of where we're going with this. So you'll see that there's this square. It tells them it has side length of 1. So its perimeter is 4. So there's 4 sides, each one 1. That's 4. And the area is 1 times 1. And they're asked to collect data. So enlarge this picture to see what happens to perimeter and area. So and they're going to change it by moving the red square right here, and it enlarges this. So notice we now have, and they're just going to write down their data here, right? They're going to get a perimeter of 4 and an area of 8. Okay, so that's interesting. I'm sorry, I think I did that backwards. Sorry, 8 and area of 4. There, that made more sense. I'm getting confused. And they're going to continue that, and they're hopefully going to see a pattern that the perimeter is, if you increase, so if you look at the length of the side, the perimeter is always 4 times that. And if you look at the area is whatever the side is squared. And that's what we're trying to get them to see, that they're not enlarging at the same type of rate. One is linear, one is exponential. So, and then you could graph it. So I'm just going to type in here what I already know. 12. And the students would be doing this, right? If they can't figure it out, they can be calculating. They can move it physically and see the numbers right there. And they have to remember that area is a square unit and this is a linear unit, right? So then we have 16, and this is always interesting for students to see. And 5 is 20 and 25. And then 6 is 24 and 36. And then you could, it's not necessarily part of the activity, but you could graph this so that they can see how the growth is impacted or what it looks like. So a scatter plot's a really nice visual of this. So there is what the perimeter, as the sides increase, the perimeter is going up at a constant rate, right? So a linear rate times 4, that's our constant rate if we wanted to find the slope. But now let's look at the area. And it's going to be a very different kind of scatter plot. Let's move this out of the way. And you'll see that it is exponential, right? It's curving. It's going up the square of whatever the side is. So this is the start of this. Then they move down, and they're going to basically now look at not specific one at a time measure changes, but what happens if you double it? What happens if you half it? What happens if you triple it? They don't have to actually move this. This is nice. You can use, so they're still collecting data. And let's say from this first one, they sort of already have an understanding. So maybe they make a conjecture. If I double it, that means I am doubling the perimeter, but maybe I'm quadrupling, so they could make some conjectures, but now we can test them out. So if I click these hide show buttons, this is nice. It shows me the next thing. And so you can see that perimeter is 32 and area is 64. So that does seem to be what our conjectures are about, right? So then they look at the 1/2, and you can turn these hide and show things off if you don't want to see them all at the same time. But if you do, it's kind of a nice visual where you can, and we probably want to move this area just a little bit out, but you can see all of them and see how growth and how that impacts the graph. And then you could plot this data and also look at it algebraically, looking at it on the graph. So we could, let's go back to our numbers here. So doubling was 32 and 64. So the perimeter doubled, but the area quadrupled as we conjectured, right? And let's look at halving. And so halving, we're thinking we're going to have half the perimeter and the 1/4. So the opposite of quadrupling, 1/4, quartering the area, right? And then if we look at the triple, we get 48 and 9 times, right? 144. So it's making these connections. So they're doing all of this before and you could graph, again, not necessary, but it's a nice visual to look at it so you can see both. And let's do another one. And again, horrible color. There we go. And so then again, we see the linear growth for the perimeter and the quadratic growth of the area. And that's what we're trying to get them to. And now we're going to go back to our actual problem. So you have this understanding that if I enlarge, my perimeter changes that same amount, but my area is going to be an exponential. And so then they're going to actually talk about it and make that connection to the actual problem. So it's really important in this to go through these explorations of perimeter and area, ratios, proportions, those types of things. How do things change if you change the dimensions?